Hello and welcome to this episode of Math with Martinez. In today's video, we are going to be looking at inverse relations and their also inverse functions. So let's go ahead and begin. What exactly is an inverse relation? Well, we will denote it, or the way that we write it, the inverse of a relation is written as R and then to this little -1 power. That's the way that we write. If R is our relation, the inverse is R inverse. That's how we read this. R inverse. We read this as R inverse. And in order to find the inverse of a relation, all that we need to do is switch the x and y values of our relation. That's the same thing as saying reverse the domain and the range. So a one-to-one relationship is simply a function that has a one-to-one relationship will occur if the relation and its inverse are both functions. So let's look and see if we can find some of those down here in these examples. Now we're going to need to remember something really important here. This I have highlighted in the margin. A reminder, what exactly is a function? A relation is a function if every input or x value has exactly one output value. That's your y value. So let's begin to look here at the very first example. And what we want to do is find the R inverse, which means we are going to, like it said here, we are going to switch the x and y values to find the inverse, which means I'm going to take these values of each coordinate and I'm going to switch them so that now what I have is -2, 1. I switch the x and y values. I'm switching those around. The next one would be 4, 2. I'm not changing their signs. I'm just switching their position. So now the x is the y value and the y is the x value. See how that's switching around? This is our inverse. Now, we are asked, is R a function? Do we have for every x only one output? Well, let's check and see. I have 1 being paired with -2, right? I've got that 1 being paired with -2. Is 1 ever going to be paired with anyone else? No, it's not. Then I'm focusing in here on 2. Is 2 ever used again? No, it's not. Each of these x's is unique and different and is with, therefore, a different output. So is the original a function? Yes. Now let's check on our inverse. We have -2, 4, -1, and -2. Oh my goodness, do you see this repetition here? Do you see how -2, this x value, has actually 2 different partners? -2 is paired up with 1, and -2 is paired up with 4. That is not a function. So, ladies and gentlemen, we would say no, R is not one-to-one because we couldn't say yes both times. Let's look at example number 2. We first want to go ahead and begin by writing the inverse. That would mean that we need to take our x and our y's and switch them. So we would have 5, 1, 6, 1, -4, 3, and 9, 4. That is the set. Now let's begin to answer the rest of the question, is R a function? Well, let's look at our x values, and do you see that repetition? Do you see this repetition that 1 is paired with 5 and 1 is paired with 6? That is not okay. That is not a function. Now let's check the inverse. We have 5, 6, -4, and 9. Those are all unique x values, and so there is no repetition. The inverse is a function, but because they were not both, right, like it says here, the relation and its inverse have to be functions for it to be 1-to-1. Because we didn't say yes both times, no, it is not 1-to-1. All right, now let's think about what the relationship is here with these values. We're told that x's include these values, and they're going to these y values. 0, 6 is the first value. So if we're going to write the reverse of that, that would be, instead of 0, 6, it would be 6, 0. Next, we have 1 going with 2. 1, 2, 1, 2. But the inverse of that would be 2, 1. And then we have 11 to 6. 11 as the x, y being 6. So the inverse would be what, ladies and gentlemen? It'd be 6, 11. All right, so the question is, do we have a function? Is R a function? Does every x go to just one unique value? It sure does. It is happening here that our x's are never repeating. If we would have had something like this, eek, that would have been a problem. But we don't. We're okay. We don't have an x value going to 2 places. Our x's are only going to 1 place. Now, what about the inverse? Is that a function? Do you see how we have a 6, a 2, and then a 6 once again? Ladies and gentlemen, no, this is not a function. So is it a 1-to-1 relationship? No, it is not. Now, this is a good way to assess things when you're given just points like ordered pairs like we have here. But then there's also, what if we're looking at a graph? And that's where the horizontal line comes in. Remember with me, the vertical line test is used to determine whether a relation is a function given a graph. That's what we've seen before. But now the horizontal line test is used to determine whether the inverse of a relation is a function. Both the relation and its inverse must be a function in order for it to be a 1-to-1 function. So let's take a moment to decide, do we have a relationship here? Do these graphs show a 1-to-1 function or not? We'll need to do our tests to determine. First, let's use the vertical. Let's use our vertical line test and see if that passes. If I were to run a vertical line across this, right? Like if I did that at any point on this graph, if I went ahead and like ran a vertical line anywhere on here, how many points on the graph of this function would I be touching? Just one. So because it only touches once, it passes that vertical line test. And the original is, in fact, a function. So we can say that this R is a function. Now let's use our horizontal line test. Now we'll run our horizontal line across this and see if I run a horizontal line, how many points on that graph am I touching at a time? Only one. So that means that the R inverse is a function. Because both the vertical line test and the horizontal line test worked, this, ladies and gentlemen, is a one-to-one relationship. Now, what about the next one? Let's check and see about this guy. If we run the vertical line test, if we run a vertical line test across this, how many points will it ever touch at a time? Does it pass the test? It sure does. It passes. So R is a function. But if I take and run a horizontal test on it, if I run that horizontal test on it, whoa, do you see how we're touching several points on that graph? It does not pass. It is not passing. So R inverse is not a function. And because one of these was not, this is not one-to-one. This is not one-to-one. Although running the vertical line, we find that the original is a function, its inverse is not. So it is not a one-to-one relationship. Ladies and gentlemen, that is all for today's video. I hope that that was really informative. If you have any questions, please will you take a moment to share those now. And until next time, stay fired up, you guys.